Hello everyone, this is Professor Gant, and this will be the first of many videos that will cover the Module 4 homework for Math 109, General Education Mathematics. What I'm going to do first is list out the problems that I'm going to do in the order that I'm going to do them, and then of course we'll work through those problems and I'll explain any background information that we need to know before we solve those problems. How I'm going to do it is, of course, I'm going to list the problems out, and then you see that I have the setup to where I'm going to have the actual question that I will have in my math lab, and then of course I'll do my work on the side. I encourage you to work with me through the problems as you watch the video. I think that's probably the most efficient way to do it, or the videos, I should say, because there'll be several videos I'll record. So if you work through it as I'm explaining everything and working through it with you, I think that will help you get through the problems faster, but at the same time still understand what is going on. So the problems that I'm going to work in this particular video, in the order that I'm going to say them here, are going to be number 1, 17, 14, 19, 2, 3, 18, 20. Then I'm going to go from 5 through 7, 22, and 24. And again, the reason why I'm bouncing around is because what I've done is just ordered everything in terms of topic. And so I'm doing these problems as the topics of the underlying problem kind of go together. So all the problems that I've just listed here are going to go over either solving linear equations, graphing lines, or finding an equation of a line. So all this stuff kind of goes together, so we're going to put it together. All right, so now that we know what problems we're doing, we'll go ahead and get started here. And we're going to go ahead and erase these. So you may want to pause the video and write these down just to make sure that you keep up. All right, so for our first question, we're asked to solve this linear equation. S is equal to 5m plus 5w for m, okay? And so when we solve these kind of equations, the goal here is just to get the variable that we're told to solve for by itself. In this case, we want m by itself. So we need to do whatever it is that we need to get m by itself. The way that I'm going to do this, I'm going to keep it simple. Since we want m by itself, then it means that we want 5m, this term, by itself on this side. So we have to subtract 5w from both sides in order to get rid of this, because we know 5w minus 5w will come out to be 0. And of course, s and 5w are not like terms because s is a different variable than w. So all that we can do is just write s minus 5w here, okay? And of course here, we know that this is 0. 5m plus 0 is just 0. So we could actually just get rid of that. Finally, we have 5 times m by itself. And in order to get m by itself in this case, we have to divide both sides by 5. And when we do that, we know that here 5 divided by 5 reduces to 1. And 1 times m is m. And so that's how we legally get m by itself. Here we have s minus 5w divided by 5. And this is your final answer, okay? For some of you, if you want to write this different, how you would have to write it different is you would have to separate this into 2 separate fractions like this, and then show here that 5 divided by 5 reduces to 1, and you would rewrite it this way, okay? So either this answer or this answer is acceptable. And I'm just going to write the first one because I think it's easier to deal with typing it in that way. So I'll go ahead and do my fraction here. And these little icons down here are just helping you to be able to type the stuff in. So I have S minus 5W and all of that divided by 5. And we check answer and we're good to go. All right, so that is our first problem. So now I'm going to jump to number 17. So what number 17 asks us to do is to solve for M again. So I'm going to erase this stuff over here, and then we're going to solve for M here. All right, so for this question, we'll go ahead and write out our equation first. And so again, we want to get this term, the M, by itself. So the easiest way to do this is to multiply both sides by 2. Okay, and the reason that we want to do that is because if we multiply both sides by 2, we get rid of this whole fraction over here. Okay, so I'm going to erase this, and we're going to multiply both sides by 2. So that means that on the left side, this just becomes 2b. And here, when we multiply both sides by 2, this is like me saying m plus v divided by 2 times 2 over 1. Okay? And here we know that 2 divided by 2 reduces to 1. And 1 times anything is just that anything. So we have effectively rid ourselves of the fraction. Now, to solve for m, we just need m by itself. And since m is being added, or since v is being added to m, we have to subtract it from both sides so that when we do here, we get 0. And again, 2b and v are not like terms because they don't have the same variables in it. So all we can do is just write it like that. And of course, m plus 0 is just m. So we just get rid of that and just do m, and that ends up being our final answer here. Okay. Now, when typing in this answer, make sure that you type it in exactly how you wrote it, or exactly how I wrote it here. In math, a capital B is different than a lowercase b. So make sure that you write this in as 2 times capital B minus lowercase v. Okay. So then we're good on that. So now we're going to go ahead and move on to number 4, well, move back to number 14. All right, so for number 14, this problem is asking us to solve the proportion. And so here you may remember from high school when you had questions like this on your standardized test or whatnot. But basically what this represents here, this 3 colon x, is just 3 divided by x. And so we're saying 3 is to x as 12 is to 32. And we want to find out what x is. The reason why they say solve a proportion is because what a proportion is defined to be is 2 fractions that are actually equal to one another. Okay. And so normally you'll see it kind of like this situation here. So if we translate, this will be 3 is to x as 12 is to 32. Okay. And so from here, we need to solve for x. And so the quickest way to do this, since we have a proportion, is to do what we call cross multiplying. Okay. When we cross multiply, what you're actually doing is 2 steps in one. When we do this, what you will actually be doing is multiplying both sides by 32, and at the same time you'll be multiplying both sides by x. So really, if we multiply both sides by 32x, that's essentially what we're doing here. Okay, So I'm going to cross multiply. And if we do that, I'm going to keep this simple. So I know that 32 times 3 is 96, but I'm just going to leave it as 3 times 32. And x times 12 is just 12 times x. Okay. And so here, once I'm at this point, I can divide both sides by 12 since I need to get x by itself. And I know that 12 divided by 12 is 1. And 1 times x is x. And over here, the reason why I didn't multiply this together is because even though I could do a 96 divided by 12 and get the answer that way, here I know that 3 divided by 12 is the same thing as 1 over 4. And I know that because 12 is just 4 times 3. Okay, so if I have that, then here this 3 divided by 3 reduces to 1, and I just have 1/4 left. So here I can reduce that to 1, reduce that to 4. And now all we have is 32 divided by 4, and of course 32 divided by 4 is just 8. So our final answer here is just x is equal to 8. And if you notice here, they already have the x equals, so all we need to do is just type in the 8. Okay. Now, for those of you that don't like the way that I just did it here, what I could do is just work it the normal way, and I'll go ahead and erase this. If we feel better this way, we know that 3 times 32 is 96, and x times 12 is 12x. And then you just divide both sides by 12. That reduces to 1. And of course here, 96 divided by 12 is 8. So you could do it that way. The reason why I did it the other way first is because whenever we have proportions and we're dealing with bigger numbers or numbers that aren't easily factored down, for those situations, it's actually a bit more tough to try to work that without a calculator. And so I'm used to working things without a calculator as much as possible. So that's why I did it that other way. But if you're fine with just doing this and you want to type in 96 divided by 12 and you calculate and get 8, that's totally fine with me, as long as you get what the answer is. All right, so now we're going to turn over a new leaf here, and we're going to focus on graphing lines and applications of graphing lines. So our next few problems will focus on that. All right, so our next set of problems here, we're focusing on graphing lines. And so before I get into this question here, I want to talk a little bit about lines in general. So whenever we talk about lines, of course, we know that general line will look like this, or like this, or like this, or like this, okay? And we know that lines, they're going to have either one of these 4 profiles here, where if it goes up from left to right, the slope is positive, and slope is just the incline of the line, meaning rise over run, and I'll write that down here. And rise is just our really unfancy way of saying we want the change in the y values over the change in the x values. And so where this comes from here is that in order to find an equation of a line, we need 2 points. And each point has a x coordinate and a y coordinate. And so what I'm doing here is I'm just writing a line, or drawing a line, where this first coordinate would be x1, y1. Second coordinate here would be x2, y2. And if I wanted to find out what the slope of this line is, I would basically do the change in the y values over the change in the x values to figure that out. And that's what this equation is here. And when that result is positive, then we have a line that goes up from left to right. So we know that the slope is positive. When the line goes down from left to right, then we know that this rise over run result is negative, and so the slope is negative. And so again, you can think of this like a person walking up a mountain. If they're walking up, the incline is positive. If they're walking down the mountain, the incline is negative. Okay. In this instance, when it's horizontal, we say that the slope is equal to 0. Okay. Notice I did not say that the line did not have a slope. I just said that the slope was 0. Okay. So it's two different terminologies here. Now, I understand that saying that the line has no slope and the slope being 0 should be similar, but here, for purposes of how we answer these questions, we have to give a numerical answer. And so that's why I'm encouraging you to say that the slope is 0 versus saying that it doesn't have a slope. Okay. And part of the reason for that is for this last line. So here, when we say that the slope or the line is vertical, we say that the slope is infinite, meaning that the change in y or the change in x is going to be an infinite value here, because for any point, and I'll draw this here. So if I have 2 points on the graph of a line here, if my x coordinates for x1 and x2 are exactly the same as it will be here, then I will have some number divided by 0. And of course, we know that any number divided by 0 is undefined, because we can't divide something by nothing. Stretching that idea, saying some number divided by 0 is another way of saying we're taking something and trying to divide it by an infinitely small number, which if we take something like that, you'll see that that number just tends to get larger and larger and larger and larger. And so that's why we say that the slope is infinite. And since infinity is not an actual real number, then another way that we say this is that the slope is undefined. And I'm just going to put UND period for short. Okay. Now, I'm saying all this because in the problems that we're going to work beyond this one, we need to know this information. Okay. Now, for the question that we have in hand, it says find the slope and y-intercept of the line. So just by looking at this, you can tell if we had to graph this line, it would look one like this one, because here the slope is -4. And I'm going to get into why we know that now. So I'm going to erase what I have here down at the bottom, and then we'll get into the equations of the lines. All right, so for the equations of lines, we have 3 types. We have the most popular, which is called the Slope-Intercept Form. And this is the most popular because this M that's right here represents the slope of the line that gives it its shape. Either it's going to go up from left to right, down from left to right, flat from left to right, or vertical. Okay. This B here is what we call the y coordinate for the y-intercept. I'm just going to say y-intercept for short. Okay. So your actual y-intercept is going to be the point 0b, but this just lets us know what the y coordinate is for the y-intercept. Okay. So again, if I was graphing the line that's given to us here, I could rewrite this way. And if I was drawing it, then what I would know is that here on the y-axis at -3, I would have a point and the graph would have to go down from left to right. And I know that the slope of this particular line would be -4, okay? And so that's what they're asking us here. Identify the slope. And then they want us to identify the y-intercept. And do you see how the y-intercept is actually a point on a graph? We call them ordered pairs. And we say that they're ordered because whenever we do x, y, anytime you plot a point on a graph, you have to figure out what the x coordinate is first, and then you do the y coordinate. And so here in this case, we know that this number ends up being -3. So that'll be the answer to that question. All right, so before I move on to the next question, which will be number 2, I'm going to finish my discussion about equations of lines, just so that you understand the 3 different forms of an equation of a line that we have, because we're going to use one of these forms here to help us do some subsequent problems. So I'm going to erase what I have here, and we're going to talk about those other forms. So we have the slope-intercept form. We also have what is called the point-slope form, okay? And so what the point-slope form does is, if we're given a situation like, hey, I want to find out an equation of a line where the slope is, let's say, -2, and I know that I have a point -1, 5 on the line, okay? Then here I can plug in that information and just solve for y here and end up with a slope-intercept form of an equation of a line, okay? And we normally use this form of an equation of a line to do problems just like what I've stated. Whenever we're given information about the slope of the line and a point, or if we're given just 2 points, and if we have 2 points, we can find the slope of the line and then use the same information here, slope and a point. We can plug in that information, just solve for y, and we can figure out what our equation of a line will be, okay? And so, again, whenever we start to work on problems where we have to find the equation of a line, this will be the equation that we'll use. The only reason why we would not use this one and use this one is if the information that's given to us lets us know that we have a y-intercept. For an example, if they said that, hey, find the equation of a line that has a slope of -2, and we know that we have the point 0, 5, then we know that this is a y-intercept by definition. And I could easily just say, well, hey, the equation of that line is just going to be y equals -2x plus 5. And we know that because, of course, by definition, anytime we have an x coordinate being 0 and whatever the y coordinate is here, we know that this point is actually on the y-axis. And if it's a part of a graph, then we know that we call it a y-intercept, okay? Last thing, we also have another form of an equation of a line, which is called the general form, okay? And so this form is mainly used whenever we do systems of linear equations, or if we're given, let's say, this equation, we're asked to sketch a quick graph of the line. So for instance, if I had something like this, 2x plus 3y equals 0. Oh, sorry, not 0. Let me do 6 here. Yeah. So if we had this and I wanted to figure out what this graph of the line looks like, I can easily just say, hey, let me figure out what y is when x is 0, and let me figure out what x is when y is 0. And I can just plug in 0 into here. And you see, if I do that, all this becomes 0. 3y equals 6. So we know that if we divide both sides by 3 here, we would get 2. So y would be 2 in this instance. And if I was to now let y equal 0 and do the same thing, 3 times 0 is 0. And of course, 0 plus 2x is just 2x. And then of course, if we divide both sides by 2 here, we would get x is equal to 3. And so literally all you would have to do is just say, hey, I got this point 0, 2, 3, 0, graph the line, and it'll look like that. And so that is what another reason for the general form. What we will focus on mostly for this set of notes will just, well, not for this set of notes, but for this particular assignment here will be these first two, okay? But I did want you to understand that if you're given problems in this form, why they're doing it. All right, so we're going to go ahead and move on to number 2 now. All right, so our next question, which is number 2, is asking us to find the intercepts and then use them to graph the equation. And of course, the equation that we have here is a linear one. And we know that the equation is linear because the exponents, the highest number on any exponent that we have here is a 1, okay? And we know that because here x is the same as x raised to the 1. Anything that's raised to the power of 1 is just itself, okay? And same thing with y. Y raised to the 1 is the same as y. So we're looking at this, and as you see, this equation is of the form of the general form that we talked about. So we know an easy way for us to figure out what the points are going to be, which they're calling the intercepts here, so that we can graph this line, is we are going to let x be 0, figure out y, and then let y be 0, figure out x. When we do this one, what we would have found is the y-intercept. And when we do this one, let y be 0, find x, what we would have found is the x-intercept. And so that's what they mean here by the intercepts. Now, if we let x equal 0, then here, when we plug this in, 3 times 0 plus 4y equals 12. We know that 3 times 0 is 0, and 0 plus anything is just that anything. And then here, to get y by itself, we divide both sides by 4. Since we are multiplying 4 times y, we have to divide it to get y by itself, because we know 4 divided by 4 is 1, and 1 times y is y. On the right side, 12 divided by 4 is 3, and so we know that we have this point 0, 3 here, okay? So in terms of the point that's going to be on the graph, we know one of those points is going to be the ordered pair 0, 3. Okay. Now, if we let y equal 0, instead of letting x equal 0 here, we plug in 0 for y and we solve for x now. So similar, 4 times 0 is 0. 3x plus 0 is 3x. And we divide both sides by 3. This reduces to 1. 1 times x is x. And 12 divided by 3 is 4. So that means we have a 4 here. And of course, the other point that we know is the point 4, 0. So now that we know that, we come here and we click on this icon. And what they want us to do is to use this graphing palette, and we're going to use this particular tool here, which is called the line tool. Now, when we click it, do you see how we have the points? You see how the points are changing in your upper right hand corner of this small window here. And what we want to do is we want to plot the point 0, 3 and 4, 0. So we're going to do 0, 3 first. So we come here, we plot it, we start here at 0, 0, and 0, 3 says we go no units in the x direction, but 3 up in the y direction, okay? Now, after we do that, do you see how the directions say click the graph to plot the second point? So our second point is the point 4, 0. So starting here again, 4, 0 tells us go 4 units in the positive x direction, and no units in the y direction. And so we're here, we have a line, save, check our answer, and we're good to go, okay? So that is one way to be able to graph this particular line, okay? Now, I'm going to do a similar question to this one, just to show you that if you want to take a different approach of graphing a line like this, you can do it that way as well. So I'm going to go here and I'm going to click similar question, and I'm going to go ahead and erase this, and we're going to do this a totally different way now, okay? All right, so the way that we're going to do this similar question is we're going to use more of the rise over run approach. And if we do it this way, there's a little bit of calculation at the beginning, but then from there, we mainly use concept to be able to figure out where everything's going to be, okay? And here, I'm just going to go ahead and write this down. So this is 5x plus 3y equals 15. And so here in this case, what we could do is solve for y, okay? To do that, we would have to subtract both sides by 5x. And that goes to 0, and we just end up with 3y. And here this would be 15 minus 5x, and I'm going to rewrite it as negative 5x plus 15, because that's the same thing, so that we can have this in the y equals mx plus b form, okay? Now, we need to divide both sides by 3. And here we know 3 divided by 3 is 1. 1 times y is y. And here we will separate this into two separate fractions. Okay? And so here we could rewrite this first term as negative 5/3 times x just on the side here. And that x is in the air. Okay? It's not, it can be assumed to be in the numerator, but you don't want to put it down in the denominator. Okay? And of course, 15 divided by 3 is 5. Now, for those of you wondering, why can I not write this way, is because whenever I have minus 5x divided by 3, this is the same as me saying negative 5 over 3 times x over 1, okay? And of course, here we know that x over 1 is just equal to x. So that you can either put it in the numerator like this or just put it in the side in the air, okay? You cannot do it like this. So just want to make sure that that is understood. All right, so let's get rid of this and finish this problem. So now we know from here that the slope of this line is going to be negative 5/3, and the y-intercept for this is going to be the 0.05, okay? So here, what we could do is, we know that we have one of these 2 points, which is 0.5 that we need, and we can use rise over run to find the next one, or the slope, okay? So remember, slope is equal to rise over run, and here we could interpret negative 5 over 3 as being negative 5 divided by 3, or we can interpret it as 5 divided by negative 3. And we know that because a negative divided by a positive is a negative, as well as a positive divided by a negative is a negative, okay? In this instance, when we have negative 5 for the rise, if we rise in a negative direction, we're going down. If we run in a positive direction, we're going to the right, okay? So with that being said, what we could do to find this other point here is, I'm going to come to the line tool again, and I'm going to graph the point 0.5. And here, what this is telling me is go down 5 units. So 1, 2, 3, 4, 5, and then run to the right 3 units. 1, 2, 3. And I click. Now, I got very lucky here because the point that I actually found when I started here at the point 0.5 and went down 5 units into the right 5 actually was a point that is on the x-intercept, okay? Oh, sorry, a point that's on the x-axis, and it ends up being an x-intercept, okay? If I had found a point using the slope and that point was not on the x-axis, then according to my directions that I had here, find the intercepts, I would have had to do it again. In other words, go down another 5 units and go across 3 to see if I could find out where the x-intercept was, okay? So in other words, if I was here, I could go down 1, 2, 3, 4, 5, and then across 3, 1, 2, 3, and you'll see right where my cursor is, that's another point that's on that graph. And I can go down another 5, 1, 2, 3, 4, 5, go over another 3, and you see I have another point on that graph, okay? Now, last thing, we also said that we can interpret this as being 5, positive 5 divided by negative 3. And in this case, this means we would rise up, which is going in a positive Y direction. So shout out to all of you Atlanta Falcon fans. And running in the negative direction will be going to the left, okay? So starting from this point here, we could go up 5 units, 1, 2, 3, 4, 5, and then run negatively to the left 3, and you see that we have another point on that graph, okay? All right, so my point here is that if we wanted to use this way, we could start with the Y-intercept, which is at 0, 5, go down 5 units and then over 3, and we find another point, and that point just so happens to be an X-intercept, which is the one that we want. So we click, check answer, and you see that everything's good. All right, so we're going to go ahead and move on to question number 3 now. All right, so for this one, same kind of thing. So we could either do the first approach, which is we can let X be 0, find Y, and let Y be 0, find X to find our intercepts that way, or we can do the rise over run. For this one, I'm going to just do the I'm just going to do the whole thing of just finding the X and Y intercepts, since you have an idea of how to do both, and I think just finding the X and Y intercepts directly would be the easiest way to do this one, so I'm going to do it that way. So for here we have X minus 4Y equals 8, and here we let X equal 0, find Y, let Y equal 0, find X. So if we let X equal 0, then here that will be 0 minus 4Y equals 8. And of course, 0 minus 4Y is minus 4Y, and that equals 8. And then we just divide both sides by negative 4. And negative 4 divided by negative 4 is a positive 1. 1 times Y is Y. And then 8 divided by negative 4 is a negative 2. So we have negative 2 here, which means we have Y-intercept point 0, negative 2 on the graph. If we let Y equal 0, then here we say X minus 4 times 0 equals 8. And of course, 4 times 0 is just 0. X minus 0 is just X. And we see here that X equals 8. So we have this, and this means that we have another point on our graph, 8, 0. So here we click on the icon again, click to enlarge graph, and we graph our 2 points. Click on the line tool, and I'll graph the point 0, negative 2, which I start here. Go down 2 units vertically, but go no units in the X direction. And then start from here, go 8 units, positive X direction, no units in the Y direction. And click save, and we're good to go. All right, so next we're going to move on to question number 18. All right, so for question number 18, this question asks us for which of the lines of the given graph do we have an undefined slope. Okay, and if you notice, one of the reasons why I talked about what the lines look like in terms of the slope is because of a question like this. And I'll remind you, here, if we have a line that goes up from left to right, then the slope is positive. If we have a line that goes down from left to right, the slope is negative. If we have a line that is flat, or we call it horizontal, the slope is 0. And whenever we have a line that's vertical, we know that the slope is said to be undefined, or sometimes we say that the slope is infinite. And so here, if we're asking to see if a slope is undefined, we're looking for the vertical lines. And the only vertical line that we have here is line C. So If we pick line C here, that should be the only one that has an undefined slope. All right, so now we'll move on to question number 20. All right, and this is an application problem. So let me erase this and then we will go ahead and work through it. So it says a health club charges a yearly membership fee of $65 and the members must pay $2 per hour to use its facilities, okay? So we see here that we have a total cost type situation, which is variable cost plus fixed cost. And of course, the fixed cost is our yearly membership of $65. We got to pay that no matter what, okay? And the $2 per hour is going to be the variable cost because that cost varies on how many hours you use the facilities. So if we want to do total cost, and I'll just call this C of T, then we know that the fixed cost would just be 65, and we know that the variable cost will be 2 times the number of hours, where T is just going to be number of hours we use the facility, okay? So if we look here, it says, how many hours did Jillian use the club last year if her bill was $421, okay? So there's a part A and part B to this. Part A is basically saying, write the equation that describes the situation, and then part B will be actually finding out how much time, or in this case, how many hours did Jillian use the club, okay? So we know that for our equation here, it says, let B be the amount of the bill. So here I'm going to erase this C of T here and just write this as B per what they tell me. And if we use this, then we should have something that says B is equal to 2T plus 65, okay? And so in this case, I believe answer B would be the best choice here. All right. So now what we're asked to do for part B is, if we know that B is equal to $421. So if B is equal to 421, we need to find out what T is. So here we let B equal 421 and we solve for T. And as you can see, this goes back to the very first question that we did whenever we were talking about solving linear equations for a specific value. Now, we need this term by itself because this one has the T in it, so we have to subtract 65 from both sides first. That will go to 0. This will be 2T. And if we subtract 421 from 65, that will be 6. Let's see here. Do that, it'll be 6. And 41 minus 6, that will be 35. So we got 356, okay? And then from here, we just divide by 2. We know that we get T here because 2 divided by 2 is 1. 1 times T is T. And of course, if we get half of 356, that's just going to be 178. And so that means that Jillian spent 178 total hours in the gym or in the facility. So, and I'm just going to double check my calculations just to make sure everything is good. And it looks like it is. And we're good to go. All right. So now we're going to move on and we're going to focus on finding the equation of a line given information about that line, okay? And so it'll be different than this first question here, because this was more like an application of total cost. It's going to be more of the type, I give you the slope and a point and you figure out what the equation of the line is. Or I give you 2 points and you find out what the equation of the line is. So we'll move on to that, and we're going to start with question number 5. All right. So for this question, it says find a linear equation whose graph has the indicated slope and passes through the given point. So for this one, we want to find the equation of a line where the slope is 3 and the point that we're given is the 0.53. And this is the x coordinate, that's the y coordinate. Now, notice that we have the point and we have the slope as far as information. So we want to use the point slope form of the equation of a line. Okay. So here we're literally going to plug in the information that's given to us and use that to come up with the equation of a line in slope-intercept form. And we know that because it says y equals. So after we're done with all this, we're going to put our answer in y equals mx plus b form, which is slope-intercept form. Now, we know here that our y1 is 3, so y minus, and then we put y1. Our slope is 3, and our x1 is 5. Now, notice I did not put anything in here for x. I didn't put anything here for y. And the reason for that is, if my result has to be in this form, I have to have an x here and a y here. And these are going to be variables saying that, hey, our line, depending upon what value of x you plug in, you give me a value for y. But this x sub 1 and y sub 1 is reserved for a point that you know is on the graph to help you to be able to find what the actual equation of the line is. So that's why we plug in x sub 1 here, 5, y sub 1 here to be 3, and nothing here and here. So from here to solve for y, we just distribute 3 to both terms. And then after that, we add 3 to both sides. And then, of course, negative 3 plus 3 is 0. 0 plus y is y. Bring down the 3x. And negative 15 plus 3 is a negative 12. And so this ends up being our equation of the line. And here we just need to type in the 3x minus 12 part, since they already have the y equals. And you see that we're good to go. All right, so we'll move on to question number 6 now. All right, so for our next question, similar thing. Our slope is 3, and the point now is negative 6, 1. So we'll just go ahead and say m is 3. The point that we have here is negative 6, 1, where negative 6 is our x coordinate and 1 is our y coordinate. Just like how we did in question number 5, we know that we're going to use the point slope form of an equation of a line. Here, y minus, we know our y1 is a positive 1, so we plug that in. Our m slope is 3. We don't put anything for x. And notice here that our x1 here is a negative 6. So when we do that, we have to do negative 6 in parentheses like that to make sure that we respect the fact that x1 is actually negative 6. Okay. Just because you have a minus here, that doesn't automatically count for this particular point here. So now we do what we did last time. We need to get this in slope-intercept form. So we need to first distribute 3 to both terms. But before we do that, we want to make sure that we take care of what's on the inside here. And of course, we know that subtract a negative is the same as addition. So come here and write this, and then we'll distribute to both terms. And so 3 times x is 3x, and 3 times 6 is positive 18. Bring down the y minus 1, and then we just add 1 to both sides. Negative 1 plus 1 is 0. 0 plus y is y. And we end up with 3x plus 19, because when we add 18 and 1, it gives us 19. So just like how we did on the last problem, we see that our answer here is just y is equal to 3x plus 19. All right, let's move on to question number 7. So we see for question number 7, what's different now is that our slope is negative instead of one of our coordinates for the point that's given being negative. So here our slope is -4, and our x and y coordinates here are both positive in this case. We still use point slope form of equation of a line. Y minus our y1 is 4. Our slope now is a -4, and our x1 is 7. And so here we distribute our -4 to both terms. -4 times x is a -4x, and a -4 times a -7 is a positive 28. Bring down the y minus 4 on the left side, and then we just add 4 to both sides. And we end up getting y is equal to -4x plus 32. And that ends up being our answer for number 7. All right, so now we'll switch gears here and move on to question number 22. I think the last two problems that we have in this particular video are 22 and 24, and they should be application problems. So we'll go ahead and move on to that now. All right, so for number 22, it says that Juno, or Huno, depending upon how you want to pronounce that, has 2 part-time jobs. Her job at a deli pays $4.99 per hour, and her work at a pet store pays $7.39 per hour. Since she earns, it says that she earns $135 in a given week, and we want to write an equation that models this situation. We are told to let D be the number of hours she works at the deli. So we'll just say D is equal to number of hours at the deli, and let P represent number of hours that she works at the pet store. Okay. And we want to write this equation here. So we know that working at both of these jobs, she makes $135. Okay, and that has to equal to the $4.99 times the number of hours she works at the deli, and that will just be represented by D, plus she makes $7.39, and that will be times the number of hours that she works at the pet store, which would be P. So our equation here should be 135 is equal to 4.99D plus 7.39P. So we'll just go ahead and type that in. And make sure that whenever you type in these variables, if you notice they use lowercase d's and lowercase p's. So make sure that you also use lowercase d's and lowercase p's. Because if not, the system will count your answer incorrect for that. All right, let's move on to number 24. All right, so for number 24, which would be our final question for this video, it says, according to a sleep foundation in the year 2012, a certain nation averaged 6.4 hours of sleep each weekend. In the year 1909, they averaged about 8 hours and 15 minutes of sleep per weekend. We want to model this data by a linear equation and then use it to predict the year when the nation will not be sleeping at all on a weekend. So let's take care of first things first. We want to model these data by a linear equation, assuming that the initial year is t equals 0. Okay? And so the initial year that we're given, which is the the year that's furthest back is the year 1909. Okay, so here talking about the year, which is 1909, and we're going to assume in terms of t, that's t equals 0, and we know that y is going to represent the amount of sleep that they got on the weekend. And in 1909, they averaged 8 hours and 15 minutes. So 15 minutes is about 1/4 of an hour, because we have 60 minutes in the hour. If we take 15 divided by 60, that's the same as 1/4, which is the same as 0.25. So that's about 8.25 if you want to put that in decimal. Now, in the year 2012, they told us that they averaged about 6.4 hours, okay? And so now what we need to do is figure out what is going to be the difference in between the years 2012 and 1909. And if we do that, we see that that's a 103-year difference here, okay? So by looking at this, they tell us to model the data that we're given here by a linear equation. And so from what we see here, this portion can be looked at as 2 points on a line, where the first point is the point 0, 8.25. The second point could be 103, 6.4, okay? And so what we're asked to do here is find the equation of the line, and to do that we need to find the slope and the y-intercept. So to find the slope, if you remember, we said that slope was rise over run, which translated to change in y values over change in x values, okay? Where here we know that we could use this as being x1, y1, and this one as being x2, y2. And it doesn't matter what point you want to label to be the x1, y1, and which one you want to label to be the x2, y2. Just whichever one you start with, you got to do the other one the other way, okay? So seeing that our y2 is 6.4, our y1 is 8.25, and our x2 is 103, and our x sub 1 is 0. And so now when we do 6.4 minus 8.25, we see we have a negative 1.85 in the numerator. And we take that and divide that by 103 minus 0, which is just 103, or 103. And when we do that, you'll see that you get a long decimal number. I'm going to go ahead and write out what that actual decimal number is, and then we're going to round it to 4 decimal places. So it ends up being a negative 0.0179661165. And we're told to round to 4 decimal places. So this is 1, 2, 3, 4. This one tells us to go up, and of course this will end up rounding to, let's see, 1, 2, 3, 4. Okay, yeah. So this should round up to negative 0.0180. So that is what our slope will be, okay? So if we come here, this should be a negative 0.0180. Now, for the y-intercept, by definition, anytime we have a point that has x coordinate of 0, we know by definition that should be a y-intercept. And here it makes sense because when this study started, which was in the year 1909, we know that it was recorded that people slept about 8.25 hours on the weekends. So that should be the number that goes here. All right, so let's check everything out. And it looks like we're good. All right, so now the second part of this asks use the equation to predict the year when the nation will not be sleeping at all. Okay. Now, if you remember here, T represented the year in which they did this national survey from the Sleeping Foundation, and Y represents the actual hours of sleep. Okay. So what we're trying to really do is figure out here is when Y is equal to 0, what will T be? Okay. So I'm going to erase some of this to kind of give us some room to work this question here. And let's see here, we need to put this back. This is 8.25. Let's get rid of this. All right, so again, what we're asking is when the amount of sleep, which is represented by Y on the weekends, is 0, what is going to be this value? And of course, from that, we can figure out what year that will be, okay? And we're asked to round to the nearest year. Now that we have an equation, we can let Y equal 0 and basically solve for T. And so what we could do here is we have this negative 0.0180t. We need to get that by itself, so we can subtract negative 8.25 from both sides. Cancels here, and we just have a negative 8.25 is equal to a negative 0.0180t. And then to get t by itself, we just divide both sides by the negative 0.0180. And here you remember any number divided by itself reduces to 1. 1 times t is t. And then of course, here we know that anytime we multiply negative divided by negative, that ends up being a positive. And so if we take 8.25 and divide it by the 0.0180, then what we end up getting is 458.3 repeating. And so in your calculators, you should see it as 0.33333. I'm just going to do 3 with a line over it. And so what this tells us is that according to our model, 458.3 years after the year 1909, people should not be sleeping at all on the weekend. So if we take that particular number, 1909, and add it to 458.33333, we'll get 2367.33333. So I'll go ahead and just write it all out here. And of course, if we're going to round that to the nearest year, that's going to be the year 2367. Okay. And if this is not right, then they probably want us to round up to the year 2368. So we'll see. Yeah, okay, all right. So they wanted us to do it that way. All right, so this concludes the first set of videos for our Module 4 homework. And of course, all of these problems dealt with dealing with things that were linear in nature, either solving for linear equations for a variable, graphing linear equations, or finding the equation of a line and doing applications for that. So thank you all for checking out this video. Please move on to the next video that I'll do, which would be about solving quadratic equations and graphing quadratic functions.